Okay. So, hello guys. Hello again. So I promised some dudes that I'm gonna speak German for some reason, because usually this would be German speaking class. So, of course I know the S word, Scheiße. I should, maybe they'll ban me for this, I don't know. Okay, I know schnell. I know ich liebe dich. And this is a challenge, okay, so bear with me. And I know hallo, ich bin Klaus und du, ich bin Sabine. The father, you should remember this too, because we took the same German class. Remember? Ping pong. Cool. So now that I spoke my entire German vocabulary, let's get to business, okay? So for the ones who didn't follow me for my past episode, because come on, let's face it, not all of you are fans, like true addicted fans to my I don't know, episodes. I'm gonna review a little bit what I did the other day. So let's see. So you hear me properly, right? Okay. So I'm gonna remove this and I'm gonna start presenting what I did the other day, okay? In case you weren't paying attention, okay? Just a quick recapitulation of what I did yesterday, okay? So actually I put it all in one project. So the beginning, as you can remember, was this file called Gabi project version 0. Then yesterday I started working on a MultiGraph implementation that will enable me to model the relationships between the notions I like to have on my app, okay? So again, a quick review of the problem would be that the entities in my domain are notions, okay, abstract notions from the realm of computer science, okay? And then I started thinking about modeling them, and I realized that I kind of need a multi-graph structure, okay? If you disagree or you have other opinions, please feel free to either write them in the Discord conversation, or just like get vocal on the discussion on Discord, okay? Because I'm gonna check it from time to time. So, okay, the idea is that once I introduce a notion, this notion can be somehow correlated to another notion, okay? Let's say like the definition of one depends on the definition of the other, but the way in which two notions are connected can be done in various ways. So the type of relationships between notions can vary. Like I explained this the other day as well. If I have the engine of a vehicle, the relationship between the engine and the vehicle has a relationship, okay? So a vehicle has an engine, right? On the other hand, there is the implementation relationship, right? Like something is something else, right? A dog is a mammal, let's say, okay? So that is another type of relationship that can be established abstractly between the notions, right? So since I'm trying to model an over-encompassing data structure to hold all the relationships I want between my notions, I thought of a multigraph because in my opinion it's an all-encompassing data structure, right? It's more general than a graph, okay? And again, I'm just gonna quickly review what I said the other time as well. We can start from the notion of a variable, which is just some placeholder for one piece of information. If I need to structure more information of the same kind, in a linear way. I can either use linked lists or arrays, right? But there's still a linearity. There is one next after the other, okay? However, if the problem at hand is non-linear, there is a branching factor involved, turning this data structure into a more general tree-like structure, right? So I need, for several problems, I need to represent them as trees. However, if I further complicate the scenario and I say that maybe you can get to one node from two other nodes or more, like this, but you can see that the flow of this structure is from left to right, okay? You don't have arrows coming back. Then you have a directed acyclic graph, which is a graph but that also holds some properties that enable better algorithms than just a regular graph. So a regular graph would be a graph in which you have cycles. I mean, you go back to a previously visited node, and then thus you can form a cycle within the structure, okay? So clearly a graph is a generalization of a DAG, directed acyclic graph, which is a generalization of a tree, which is a generalization of a linked list, which is a multiplication of a single node or a single piece of information or a variable, right? However, some problems link two different nodes with more than one edge. So this is how I get a multigraph, okay? So let's say from Paris to New York, I can either go by boat or I can go by plane. So I have two means of reaching New York from Paris, okay? So I can model this as a multigraph, right? Just a simple example of that. So now that I have a multigraph, I'm thinking that actually a variable is a multigraph with only one node. A linked list is a multigraph in which all the nodes are chained linearly. A tree is a multigraph in which I have branches. A DAG is, you know, a generalization in which I go from left to right, but I can reach one node from two different ways. And then a graph is just a multigraph with only one connection from one node to the other. Whereas the general, all-encompassing notion of a multigraph is this, that I can go from either point to either point, and there are several ways to go from one point to the other, okay? So this is just a quick recapitulation, okay? Your guys are up to speed now? Because it's 30, okay? So, man, I'm on time, as I said it by 18:30 I'll be starting work, so cool. If you acknowledge that we're up to speed and you don't have questions, I'll get on the implementation. What do you say? Can I have a green light? Good, thank you. Okay, Domnul Vancea, I'm really curious who you are. Okay, so the other day I started working on this a couple of classes called MultiGraph, so the implementation of a multigraph. So I'll start with the header file, okay? So let's use oops. Okay, so now since there's more of you, I made some decisions and I want to check it out against you, okay? So I'm creating a templated version of the multigraph, and I introduced the concept of nested classes. Okay, so since they are private, the class of node and edge and connection, which are used within as an infrastructure for the multigraph, they're not visible in the outside of a multigraph object from the class multigraph. Okay, so this is how I create nested classes. Okay, so I need a node to represent a piece of information. So a node has an ID and the information stored within, okay, with getters and setters on that. So this is pretty straightforward. Okay, also an edge is viewed as having an ID, a numeric ID, and then you have a source and a destination, which are in fact references to the aforementioned node classes, right? Objects of that. So okay. Okay, so now I have getters and setters for this one as well, and also I try to model a bunch of edges connected. So the way I saw it, and let me know if you think otherwise. Okay, I was trying to model the fact that you still have one simple connection between. So let's say if I have two nodes that are not connected, they will not have a connection between them, right? Like these two nodes here, like this one and this one, right? So if I have a connection, that connection holds an array of edges, right? So if you have at least one edge, then you have a connection. This is what I try to model. Do you agree with this? So actually I'm saying that a connection holds the IDs of the edges, all the edges. In the case of these 2 points, is all these 3 edge IDs for these edges, right? Man, how is the? Do you hear me okay on Twitch? Do I need to change something? Okay, thank you. Okay, so I'm gonna continue. Okay, so I made this choice. Hopefully you're on board. If not, you please write on the Discord and we'll see other options. Okay, and now we're gonna discuss about the way I thought of it, right? So I thought that I will have a map, an unordered map of nodes, so like that has the key, the code, the unique code of each node, and then the value, the node. Okay, and also the same, I have an unordered map of edges that allow me, if I know the ID, to get the designated edge or node in theta of 1, because this is how fast you get stuff from that collection, right? From a dictionary. Okay, so also this is an unordered map of connection, so I need to give the users access, quick access to each node, each edge and each connection based on their IDs. So this all of get node by ID, get edge by ID, all that should be done in theta of 1 because of the ordered map implementation, right? Okay, however, how am I gonna model the relationships? Okay, so the idea is, if I take it with respect to one node, this node has different types of connections going in and out of it. Okay, so if I take this node in consideration, it has to have, like, let's say if it has this edge going from this node oriented like this, and I have this edge from this node oriented like this, and also it can go from here to here like this, and from here to here like this, and of course I can go from here to here. We have two types of connections that bind this node to the exterior, right? You have outbound edges and you have inbound edges, right? So these two are inbound because they go into the node, and you have outbound that go out of the node. Okay, so now since I need to meander through this data structure, I need to have a way of knowing the outbound set of edges for this particular node. I'm sorry, it's not edges, it's connections, okay? So outbound set of connections from this node and the inbound set of connections into these nodes, okay? So actually if we look at it from the perspective of connections, I don't have a multi-graph, I have an ordered graph of connections. But if I was to think in the terms of edges, I have a multi-graph of edges, okay? So what I did so far was not much. I just created the headers for the functions I want my data structure to have. So I need to have getters on the number of edges, number of nodes, number of connections, check if I have a connection between two nodes. So get the node info, get the edge info, okay? Get all the edges between two nodes. I mean, I can have the connection between two nodes, which is unique, but within the connection I get the unordered set of integers, for which the integers are the codes of the edges within that connection, right? Moreover, I want to see if I can get the index of the connection between two nodes, which is, again, everything is done via a number which is given here, okay, at the creation of each node, at the creation of each edge. So you can see here, right? So I give, okay, it was just a choice, right? So I can give a new ID to the node, and the ID has to be unique, okay? So I have to check that there is no such node with the same ID twice. The same for the edges, the same for the connections, but the connection is maintained intrinsically, okay? So now I have CRUD operations, right? Add edge, add node, remove edge, okay? What do I have? Did I miss some operations on a graph? Think a little bit about it and let's talk about it. Do you want some other operations here? Because I'm gonna use this as the container for my notions. We are building like a very, very sketchy framework or API or whatever you want, just an object at the moment. Cool, so up until now we're good. Let's get on the implementation, right? Okay, of course, I mean, you know me, guys, right? So we're gonna start with test-driven development. So we're gonna do tests first, okay? This is why I have this file here. Let me, okay. Okay, so in another window I'm gonna open the tests. So it's gonna be graph test CPP, okay? You can see that. Can you guys see this? Let me just custom font. Okay. Let me just check. I had some suggestion that I should increase the size of. Okay. Okay. Okay, it's better. I think you can see better now. Okay. Is it too big? Or is it better right now? Because people suggested that I use a bigger font. Cool. Okay. So I started with just checking that I can instantiate it in any form, a graph, and that the destructor is called correctly, and so on and so forth. And let's see what I've got so far. So let's Okay, so I'm gonna do a val grind. Okay, all blocks were freed, everything's fine. Okay, moving back to the implementation of tests. Okay, so yeah, I just tested the constructors and destructors. Okay, so now I will develop the tests first. Okay, so this is test driven development. Okay guys, I know I got my issues, right, and I am fixating on this test driven development thingy. I don't know, if it doesn't work, it doesn't work, but it kind of works for me on small scale projects like this one. Okay, like not industrial projects. Okay, but still, I don't know, if you discipline yourself to do this, maybe you will be able to reduce the debugging to a minimum. Okay, so if I'm paying attention and I'm I don't know, concentrated here and I don't make mistakes, I should reduce it to the minimum. Okay, so let's see how we do. First I need to check that the multigraph as it is created. Okay, I'm gonna use the MG. Okay, so I need to check using cassert. Okay, I'm gonna include cassert here. Okay, I'm gonna check that this graph is empty. Okay, mg number of nodes should be 0, right? So no nodes here. I'm gonna assert it. Good. And bear with me because I need to check all the possible cases, man. Like, let's see what we're gonna do next. Okay, mg number of edges should be 0 as well. Okay, of course the number of connections the same. Of course, since I've hard coded the response, I think it should pass the test. I didn't what? What happened? Man, I started with a bang, huh? So why doesn't it find because I didn't compile with it. Okay, sorry. So I need to compile the MultiGraph, right? So it's gonna be multigraph.cpp, correct? What's going on, man? This is weird. Can you help me, guys? Do you feel? Do you have any? Frankly, I don't see why this is happening. MultiGraph.age. Interesting. Let me just see what's going on. You don't have any ideas, guys? Puzzle. Now I'm as puzzled as you are. Yeah, that's you and me both. So test multigraph graph test CPP undefined reference to multigraph. Man, this is weird. Oh, yeah. I will define them all here, man. You know, cause I told you before, this is that problem that you should write templated classes in the same. Yeah. So okay, I got it now. Okay, so I just need to put all of it in the header file. Exactly. Okay, so I mentioned this before, but I didn't do it for this particular one. Okay, so I need to copy the. Okay, I got it now. I need to copy all this implementation from here, and I need to put it in the same file because of the late binding of C++. Okay, so why aren't you copying it? Okay, man, what am I doing? Let me. Whatever. Man, I'm bad at this. Okay, I'm gonna manually select this, but it won't work like this, man. This is bad. This is bad, guys. I'm sorry. Please don't do this at home, okay? I'm ashamed of me right now. Yeah, so I'm gonna put the implementation here underneath, but in the same file, okay? And now it should get it. Okay, that's good. Okay. I need to save this first. Okay, so now I just need the. I guess I don't need this because it should be empty, right? Did I misspell anything? Number of nodes. Let me just... I'm gonna erase this one. See what... I mean, it should work now. I don't know what the problem seems to be now. I think I should have... This is weird, man. Any ideas? So I thought it was because yeah, that would make sense, right? Because it's a template, so it should be in the same file. But now I've put it in the same file.
Maybe implement it directly in the class.
Yeah, I'm gonna do that, but this should be working, right? Because it's in the same file.
Yeah, it should.
Okay, okay. Yeah, I'm gonna implement it in the same class, I guess. Right. So this is weird, I have to admit. Didn't expect this. So now I'm gonna do the implementation here. Man, this is weird. If you find why this happened, please tell me as well. It kind of baffles me a little bit, okay? Of course, this is just some stubs. These are just some stubs. Man, I didn't expect this. Come on, it should be simpler than this. I must be missing something, guys. If you have, I don't know, a fresher perspective on things, please tell me. I don't think I'm in the right... Am I in the right... Man, I'm not in the right folder when I compile it. Man, this is not good. You know? I'm not in the right folder, man. I was... Man! Man, this is the... This is such a very, very cruel trick, man. You know what I'm saying? Like... Yep. Okay, it's okay. I'm sorry, man. Like, holy smokes. I wasn't in the right folder when I compiled it. Damn. Yep. Haha. I was saying, like, I have to pay attention, man, but I wasn't even in the right folder, right? Nashpa. Okay, so it's cool. Okay, so now it passes the test, but only by chance. Okay, so I'm gonna start implementing the features, right? But first, let's go on with the test, okay? What's the name of the file? It's graph test, okay. Okay. So I said assert and then so I will refactor the code, and the next time it will be more modular and more clear for me in which folder I am, okay? Sorry guys for that. Okay, now it compiles and it works. Okay, I'm gonna skip the val grind for now. I just wanna show that it passes the test. Okay, however, I will continue with the test now because it's only by chance that I'm returning 0 there. Okay, so what if I am going to add a node, right? This should be fairly easy. So I'm gonna add a node, right, with this function. Okay, so I'm gonna say mg.add node, and now for this, since a node only has an ID, let's say 0, and I need an integer, so let's say 023. Okay, because how do I know I need to put an integer? Because it's here, right? This is the information within the node. Okay, so it has to add a node, and then I have to assert that the number of nodes has increased, which won't happen. Okay, so it will crash, hopefully, and okay, it will crash. That means I have to go to work on this add a node. I have two functions to implement now. Okay, so I switched from the testing perspective to the implementation perspective in order to pass this particular test. Okay, it involves the add node method and the number of nodes method. Okay, so clearly I need to check whether I have another node in the, well, inside the unordered map. Okay, so how do I check if I already have a node in the a map? Okay, can you tell me, guys? Yeah, it works. I'm gonna separate the CPP file. I know. Okay, I'm gonna do that. Okay, so yes. I mean, see, that's why I'm the boomers, man. Boomers forget stuff. But come on, can you tell me how I can? Because this is an interactive one. I need your participation. So. Okay. So, but for this, in order to be sure, let's look at the unordered map implementation, right? So always look at the manual, man. Nothing fancy here, right? So look at the functions. Look, you have find. Let's check out find. So if you look for a key, right, it will give you, look, just this is how you do it, man. Read the manual. Okay, so you need to know what goes in and what comes out. So it says that you give it a key, a const reference to the key type, and it will get you an iterator back. Okay, so for the guys who followed me for my for the class, I presented the fuzzy pink bear scenario. You know what I'm talking about with an iterator, right? So that's what I'm gonna do. Okay, so now I'm gonna introduce a concept from the last standards of C++, which is auto, right? So if I don't wanna like mention the type of the variable, because it can be like the compiler can figure it out on its own, and it's not important to what I'm doing. I can use the name holder auto. Okay, so this is an iterator for the search, and I'm gonna say what? Where am I gonna search in? I'm gonna search in the unordered map of nodes. Okay, so it's gonna be this. Whoa. Okay, let me go up. This arrow nodes dot, and the function is find, and now I need the key, right? Node info. Okay, but I'm not gonna use that. I'm gonna use the ID, right? Because the ID is the key. So it's node ID and node info, the name of the variables. So now I'm gonna find the node ID, and what I get back is an std iterator. Okay, let me enlarge this. Okay, so I'm gonna get an std iterator, and the idea is, do you want me to get into how iterators work, or your set? It's your choice. Okay,
for me it's okay.
Okay, so you understand, you did it in your classes. Okay, cool. So now the idea is that if I don't find anything, it, the variable it, will have to be at the end of this nodes, at the iterator from the end of the nodes collection. So I'm gonna check it against an end method that usually points after the last element in the collection. Now our collection is a unordered map. Okay, so if I didn't find anything, so the idea is I can write it, I need to make this specific, okay? If I write it like this, it means that I haven't found anything, and I can say that this node, sorry, this node for the node ID, okay, will hold the information for node inf. Okay, so I can do this. Okay, but now what happens when I have a node with the same ID? So I would say throw, and I will create my own type of exception. Okay, so let's do this. Okay, but then I will get back here. So let's say I have an exception called MultiGraph exception. Okay, so the throw mechanism is that it asynchronously breaks the flow of the regular flow of the function, so it doesn't execute anything underneath that's done in the function, and then it takes this object here, and if this function is held within a catch scope, it will obtain that object thrown here and do whatever it wants with it. Okay, so I will create an object called MultiGraph exception that will say existing node ID. Okay, however, I don't like this implementation like it is now. Why? Can you tell me? So this is, it has a small bad taste in my code. Puzzle, can you tell me?
You won't get 100% code coverage.
Yeah, that's the idea, okay? So actually, when you throw an exception, as the name says it, it should be an exceptional case. Well, an exceptional case, which is not the norm, is usually branched away in an if statement like this. So maybe I should flip these two statements and say, okay, if this doesn't happen, okay, then throw the exception, okay, and otherwise do the other scenario. Okay, it's the same parallel, okay, same choices I have, but in a reversed order, and it makes more sense because if you put a throw statement in the root of your function on this level here, it will not enable you in any case, right? It means that some code, the code that's after the throw, will never ever be reached, like never, there's no chance, okay? And you shouldn't do that, okay? Because all the code should be reached by the test cases of your tests. Do you agree? So it's a bit of a bad smelling code, and it's all due to a logical error here, right? So this is why you learned logics in the first semester. Yeah, because logics usually simplifies things, okay? Everybody has his own logic, right? But there is some types of logics that are simple than the others, okay? So this is one example of that. I'm gonna go up and implement the error, okay? It's just a class, okay? It's just a class. I can implement it within the realm of MultiGraph, but I won't, okay? I'm just gonna say class MultiGraph. You have to remember I can even not make it inherit from the std exception, okay? So I'm gonna show, did I call it error? Okay. Or exception, how did I call it, man? See, I'm a boomer, I keep forgetting stuff.
Exception, I think.
Just check. Okay, it's exception, okay. But how come, why am I not consistent, you know, like I start with exception and it makes perfect sense, and then when I go up it's error. I don't like to have options, you know. Okay, so this is the class, and of course it has to have, let's do it like this. So let's say I have an, okay. I have a vector of errors, okay? So I'm gonna use a vector of string I'm gonna include the string as library as well. Okay, and now I'll just keep a vector of strings so I have messages. Okay, so public I'll need a constructor, right? Based on an array of messages. So I'm gonna say that I do this. Okay. And maybe I can overwrite the operator, right? So it's gonna be an OS, right? So it's gonna be OStream operator blah blah. Is it like that? No, it's the other way around, right? And then I have an OStream.
Also STD.
Okay, so it's an output stream, and now I need a const. So this is a friend method, of course, right? So const. Let me just. I don't know. Let me just. I'm receiving a call.
MultiGraph exception.
Yeah, sorry. I was receiving a call. MultiGraph exception. Yeah. So MultiGraph exception. Okay. And I'm gonna implement it on the outside like I should have done with the others. I mean, I'm so ashamed of what I did earlier, right? Like how I was in a different region of the code. Man, that's bad. I need to do something great to make up for that. Okay, so yeah, I shouldn't use friend here. Okay, friends will be friends. So what I do is the OS gets I'll build a string, right? So it's gonna be a string s nah, I'll use a for. Okay, so for auto const auto ampersand msg in mgue dot msgs just print the msg and then print a new line character, I guess. Okay, and in the end return the host. Okay, it should work, right? Does it make sense? Okay, let's say it does. Okay, good. So now I also have to update. I mean to update the code here. Say this number of nodes. No, this. What's the name? No, nodes. uh, dot size. Let me check it. Nodes dot size. Okay. Man, tell me it got. What? What did I do, man? Holy smokes. So my whole code went to shambles. Shit. Yeah. Okay, cool. Let me. Man, I hate these controls, man. Holy guacamole. I wanted to save it and instead I erased it. Bad. I'm gonna write it quickly, okay, and then I'm gonna save it, okay? Sorry. Okay. La 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 la. Okay. Okay, so I'm gonna save it right now, so I know it's been saved. Thank you. Won't taking any chances no more with this. Okay, so number of nodes, it's the is the size of nodes. Cool. And now it's gonna be easy to add a node, right? So it's gonna be auto it equals this find. Okay, so this is node ID and node info. Cool, so I'm gonna find the node ID. Okay, so since I modeled it as for it to throw more than one exception, because I don't know what I was thinking at that moment, but now I deal with that. So I'm gonna have a okay, so if not, I'm gonna add the pair node ID node info. Okay, okay, let's check it. Since I'm putting everything in one, I'm gonna run the compilation here as well. Okay, so that I don't move. So it's gonna be test exe on graph test. Oops. Let's see what. There are some. Oh yeah, I forgot the vector. True. Yes, I have another syntactical error. Theorem. Ah, okay. Forgot this. Always forget this, man. Never forget, okay? That to put that one. I think I should use the other function, okay? So in order to put an element, you have the insert, right? Okay, so I can use this one. I'm gonna. I should have read the manual first, okay? So it's nodes dot insert and then a pair between this and this. Okay, let's see. Was I holding nodes there or node info? Maybe I should hold node info here. Or I need to create a node with that info. Correct. Okay, so that's what I'm gonna do, okay? I skipped a step here, okay? I need to create a node. I'm gonna, based on the node ID, true. Based on the node ID and the node info. Okay, and now I'm gonna add that particular node as the information here, okay? I don't have. Oh, I don't have an explicit constructor for that, for the node.
No, you don't.
Yeah, that's cool. Okay, so well, I can't imagine why I would create an implicit one, right? So I'm gonna create an explicit one as well. Okay. So it's gonna be an int node info node ID. Okay. So I'm gonna implement it here, and then I'm gonna refactor it by the next time we'll have class. Okay, probably tomorrow. And okay, so why am I doing this? I have to use the lit version, right? So the node ID will be based on the node ID, and also the info will be okay, clear. Okay, cool, good. Now I need set get node ID, set node ID. Okay, I got this. So let's implement this as well. Okay. Node info. Okay. Okay, let's save it a little bit. See what we've got. Okay, let's see. I'm adding a node, creating a node, adding the node. Okay, let's see if it works. Okay, finally. So yeah, I need to adhere to my own rules, right? So let's see what goes on now. So it passed the test with fly colors. Cool. So not much indeed, but honest work. Okay, so we created and we added a node. Let's go to the next test. Okay. Okay, I'm gonna try to add the same node again. I mean a node with an identical ID but with different information, right? So I'm gonna say mg.add node, say 0, and what's LeBron's name? I mean, this 23. Yeah, he likes to have the same outfit as the goat. So now I'm gonna catch my error, right? So it's a multi-graph exception exe. Okay, so I need to, I don't know, I'll print it. Okay, I'll print the exception. Maybe I can introduce you guys to the S stream a little bit. Okay, so I have a string stream. Have you heard of this? Did you use it? So it combines, look, it says here that,
couple of times.
yeah, so you have eStream, OStream, you have IOStream, that this is the inheritance, right? So you have the string stream that goes from this, right? So this is just a stream in which you can either input or output or both, and it's used to populate strings, right? So I'm gonna say string. Yeah, let's see if it works like this. So it's string s. So I'm gonna have a string stream. What do I need to include for that? Let's see. So I need to, okay. Okay, so I need to include what? Nothing, just it's, oh, S stream, right, correct. So I need to include S stream. And then create a string stream. And then read the exception into that, and then check, well, then output it into a string, and then assert that the string s is equal to, what is the message? Existing ID.
Existing element, I think.
Okay, I'm gonna change it on the other side if it's not, if it's like that. The existing ID, okay. So existing ID, okay, cool. So I created a new test. I'm gonna compile it once more. SS string stream. Okay, so I need to, I think, yeah. Maybe it's because of that. Yep. Okay. Now we're cooking. Let's see what happens. Let's print the.
I think you also wrote the \n.
Oh yeah, you are right. Thank you. I did. Correct. But it's cool that it broke, because yeah, it was would have been nice if it were that, right? So let's check it. Let's print it as well.
And the
What?
OStream operator also print \n.
Oh. Oh, yeah. But why?
Yeah, and I think you have two \n.
Okay, but what if I... Okay. Okay, let's admit your supposition and see. Nope. It's not that. But we'll see, okay? Yeah, no, it's cool. I like it. So I have the C out, and I'm gonna see exactly what it prints, okay? And I'm gonna use some delimiter after it so we can see exactly what it prints, okay? How many \n are there, man? Okay, let's see. Maybe I should get rid of the \n, because it seems like a bad idea to begin with, right? So I'm gonna lose the \n from here. And then when let's see when I do this, what happens when I do this. Oh man, am I stupid. Holy shit. So now I need the \n here, right? And yeah. Okay, so I need one \n now, right? For the test.
Yeah, yeah.
So
Think.
okay. Let's try it without. I kind of complicated stuff a little bit, right? S equals existing ID. Was I writing it properly? Yeah. So existing ID, but it doesn't print my hashtag afterwards. Why? Am I returning the OS afterwards? I don't think I am.
You do.
Oh, I am. So it prints the message and then a \n, right? And then I have to have a \n. So
Yeah.
why doesn't it print my hashtag or something? Ah, I know why. Because I need a \n after this, you know? So it flushes it. It will print it like this. Yep. Okay, so what's going on? Yeah, I need the \n here. But why isn't it working like that?
Maybe get rid of the \n from the old tree.
Yeah, I could do that, but
Causing problems.
yeah, well, I had to put, see, that was a bad judgment call, right? I had to put it to have a and then I have to, okay. Yeah, now it has to have no \n whatsoever, right? Again, I'm not printing the S. Maybe the S is the problem, and maybe I didn't store it properly here, you know? Why didn't I think of that? Maybe it's because of that. See? I still need the \n, right? Maybe I didn't use the example properly, okay? Let's see. Boom, bam. See? There is no, it's just existing without the ID. Why is that? Oh man, because it has spaces. Oh man, am I bad or whoa? Okay. Okay, so I'm gonna be like I need a while here, right?
Damn.
That's bad. That is bad, my friend. Okay. Man, did I pick the short end of that stick when I modeled it like that, huh? So yeah, okay, so I need another string, and I'm saying like while SS goes to temp, kind of a bad code here, but I don't know. Okay, so I read the temp and then I append it to S, so S goes, this should be it, right? Or do you think that's, yeah, cause no, cause the SS contains all the words, but does it though? It should. Let's see if it works. It should work, right? So
maybe add a space between.
yeah, I know. That was what I was thinking right now. Okay, so let's just print it, see what happens. Man, but this is not good. Okay, existing ID. Okay. I need to remove a blah, right? Space, right? I need to remove the trailing space character, because if I put spaces here, it will get a final space, so it should work if I put it like this, right? Yeah, okay. That was good to know. That was really good to know, man, because holy smokes. How about that? So I think I have a better way of.
Instead of the
I'm sorry? What did you say?
I'm gonna use the string instead of a vector of errors.
So you're gonna use and you're gonna append to that array, okay? Yeah, but I was thinking about another approach, you know. Let me just look at this, okay? Stuff. Holy guacamole. Okay, so I was just like, I'm gonna do it like this now. It's gonna be an exception. It's gonna be like that. And now I'm gonna go to the MultiGraph implementation. What I'm gonna do is I'm gonna build a string here, okay? But is it, I don't know, I cannot do that, right? Because I will still have the same problem when I read it on the other side. Oh man, I know now. Yo, I know now. I should have also yeah. Let me think. Yeah, this is gonna be bad, okay? I'm just gonna use one string, okay? Sorry for this, guys. This is better, right? Do you agree? puzzle? This was your idea, right?
Yeah, but yeah,
Because it further complicates it without...
I think
Bring-
we're gonna stumble on the same error.
I'm sorry?
I think we're gonna have to use a while on string as well.
Yeah, but I'm gonna just like throw one error here. I'm gonna read, so this will go. I have to figure out whether I want to pass an array of errors or simply just one built string. So this is gonna be existing ID. Okay, so now I take the string out of it and I just compare it, right? This should make no, this should be it, right? Or not? No, I have to get the method, right? What's the method? Get. I don't have a method. Why? Oh, okay. I'm not gonna do it like that. I'm gonna do it like the classical way. I'm gonna get a getter for this message and I'm gonna print the message. Okay? Then we'll focus on this fancy stuff later, okay? Because this is not the issue right now. So I'm gonna implement this. Man, this was a bad choice. I'm sorry. Again. Okay. So, yeah. Let me go on. Like the blisters in the sun. Let me go on. Ta-dum, ta-da-dum, ta-da-dum. Okay, let's see. Okay, so now I need to take it manually with the getter. Okay. No problem with that though. What I should have done in the first place, okay? Actually. Okay, it passes the test. We can move forward, thank heavens. Okay, let's see what we need to do next. So I edit a node. Maybe I should add another node. Okay, so I'm gonna be mg.add node 130. Okay. Now I need to. How do I figure out? Okay, so first I need to check that the number of nodes is 1 now. And also I need to use the function that gets me the information of a node based on its ID. So now I'm gonna do this const in. I mean it's an int. I'm not gonna use a const. Okay, int info equals mg.get node info. Let me just look at it. What's the name of the function? So as you can see, I've created a function called get node info. This is it, right? Get node info over. Okay, so that's the one. I'm gonna say get node info. Okay. For 0, and then I'm gonna assert that the info is in fact 23. Okay. And then I'm gonna add this guy. I'm gonna say that the number of nodes is gonna be 2. Okay, and let's roll with it. Of course, I have to implement that particular function, okay, because I just created a stub there, okay. So now, since I have this get node info, I really need to return I have to check that that is the actual name of the function from the node implementation, right? So get node info, that's it. Okay, so it should be cool, right? We should pass the test. Let's see. Oh, so it's gonna be with I'm gonna use find for locating that. Okay, so I'm gonna say is it do they have a getter? Let's see. So unordered map, how do I get this? Oh, so it's so let me remember how I can access it. I thought I could do it with this operator, like it should work though. Let me see again, why does it break? Oh, I guess maybe it has to be const. And I didn't make it const, but I did. Well, what would be the problem here? Let's see if this works, like if I store it. shouldn't be like this. I mean, I have no I. Oh man, oh my god. What is I, man? Node ID, correct. Oh. Do you guys know? Puzzle?
No idea. Maybe print the value and see.
No, but it's here. It's the fact that I'm accessing these nodes, you know? So... Oh man.
Instead of the square bracket,
Uh...
add. Maybe it works that way.
Let me think. So... What do you say? What are you saying?
Instead of the square bracket, use at.
Okay. Yeah. Yeah, but it should work like this as well, right?
Yeah.
Okay. Okay. Because it said the operator is overwritten, right? Let me see, why isn't info? So I have only one node, right? It should be that one. Okay, let's go back. Let's
Can you
test.
print the value to see it?
Yeah, that's what I'm gonna do. So I'm gonna put a backslash n, okay? What? Maybe spy. This should be in the constructor of the node, right? Okay, so let's see what happens when I create the node, right? Did I put the wrong... Oh man. Let's see. This is weird. Okay, so the object was created correctly, right? Let's see what we've got on the other side, right? So I So the info is copied here, it's correct, right? It's made a copy of, so it shouldn't be. So when I obtain the information for the node here, let's see what I get. Okay, this is weird. So I'm adding a node, right? Oh, wait. But here, if I insert this, oh man, I know what the problem is. I guess. No, it's not. It's cool. It's okay, cause it creates a copy there. It shouldn't. Do I have a copy constructor for the node? Oh man, see? Man, am I bad at this. So I should have implemented this one, right? Okay, big mistake, but it's cool. Yeah, it makes sense, right? See, I'm just saying it's, let's make it a decent copy constructor. So you know where my problem was, right? Because I said I was gonna test the copy constructor, but I didn't actually do that, right? I just instantiated using the blah blah blah, but what was behind I didn't test, right? To see if it actually computed all that. So serves me right, okay? Every time you make a bad decision and you're not consistent, you will pay the price in due time. So there's a lesson to be learned here, right? And that's it. The no node, blah blah blah, and here you have, okay, cool. Bad. Oh my god. Boom. Okay, let me get rid of the prints. Whew. Man, why wasn't I, like, I should have been more thorough yesterday, but it was at the end of the implementation. Okay, so yep, making mistakes, learning from them, it's the process. Okay, so now I've added a node, it works well. Okay, at least we did this much. Okay, moving forward, I mean, let's create another test. Okay, at least I showed the power of test-driven development, right? Okay, now let's add an edge. Okay, so I'm gonna be like add edge between 0 and 1. So I'm gonna assert now that the number of edges now is 1. Okay, so okay, now the edge is not that simple, right? So it has to have an edge ID. I'm gonna call it 0. Then it has to have the source and the destination, and also it has to have a cost on the edge. Let's call it 45. Okay, how do I make sure that I get the right cost for the edge? Okay, so that's not even okay. Okay, this is okay, right? So the edge has all that. Good. Now I will. Do I have a function for getting the information of an edge? I should have one.
Yeah, but we don't have a constructor.
Yeah, well, I'll be implementing it, but first the tests, right? So where is it?
Okay.
So get edge info. Okay, so I'm gonna do it like this. Gonna be kind of similar to this one. So I first need to get the edge. Okay, so it's gonna be get edge info. Okay, so it's an edge, so it's called E. Okay, so this is it. Okay, let's implement the edge. So I still need the explicit constructor, right? So it's gonna be edge int edge ID. Then it's gonna have. Why do I need this like that, man? I don't, right? This is bad. I just need the IDs of the nodes, right? Do you agree with this?
Yeah.
That was the idea, right? Because once I know the ID of the node, I can easily go and in theta of 1 get the information. Okay, so yeah, the edge ID is the edge ID. So now I have int edge ID, int source node, destination node, and okay, so let's do this thing. There's gonna be edge ID based on the edge ID. Okay, then I'm gonna have the source node based on the source node. And I have the destination node based on a DST node. Okay, good. And now I have the edge info based on the edge. Okay, now I have the constructor in place. Good. Now let's not make the same mistake we did again and implement this poor fellow as well. And I'm gonna take these lines here and I'm gonna change them a little bit. So it's gonna be somehow my bugs are funny, man. Really, they make me laugh. So now let's implement these as well. Okay. Okay, so number of edges should be okay. Let's see what happens now. Did I do something wrong? Oh, I forgot these parentheses here, I guess. Or here, right? That should be okay. Because I didn't add the edge, right? I didn't implement the add edge. Okay. So let's task as a scheme machine. I'll have to change it in the other place as well. Okay. Okay, but now this is not enough, right? These two source node need to be validated. Okay, it has to connect to already existing nodes, right? So now I'm gonna check it, right? So it's gonna be now I'm looking in the nodes, right? Collection.
now we could call the isConnect function to
I'm
see
sorry?
connection between the nodes. Maybe we could.
Yeah. True. Yeah. But I still have to create the entity of edge. That goes without saying, right? So I'm gonna do that, right? Because I can do that right now. So you're saying if there is no connection, I should create a connection, but I still have to make the object, right? So it's the creator principle. When I can do when I can create the object, I'll create the object, right? So okay, so this is the object, and now yes, you are correct. So if there is a connection, then we're cool. We're just adding the okay. So if there's not a connection, I have to create a connection, right? So I need to how do I check? So this is SRK node, and this is DST node. So I need to check if there is a connection. So let's implement this first, okay? Right? So I'm gonna say this connections let's see, where do I have the connections? Oh, okay, so I need to look in the outbound connections, let's say, for the node, right? Because I don't have to, I have to have an entry here, right? So I'm not checking into the connections, I'm checking into the either outbound or inbound connections, right, of the node. But let's check it in the outbound, so it's like in the logical order of things, right? So this, okay, auto it's gonna be like this, outbound connections. These outbound connections at
Of source.
yeah, like this, right? And now in these out connections I need to find out, okay, so I'm gonna say out connections, no, so this is the iterator I need. So it is out connections find DST node, right? So now I need to check, so return IT different than out connections dot end. Does it make sense?
Yeah, I think.
So-
Can you explain what each integer from outbound connection stands for?
Well, yeah. So here, this one is the code, the ID of the source node, and for each source node, you will hold a map that has the key of the destination nodes that can be reached, the outbound connections that can be reached from that node here. So this is the source node, this is a destination node, and what I'm doing is I need to first locate the unordered map that is designated to this source node that contains all the pairs, a destination node accessible from the source node, and the ID of the connection that is created here. Correct? Is it clear now?
Yeah, okay, it's clear.
Okay, so now what I did was I first, having the code of the source node, I need to get the out connections from the node, meaning this is a dictionary map, an unordered map with the keys as all the destination nodes that can be accessible from the source node, and I need to check if my destination code is one of them, and if it is, it means that there is a connection, right?
Okay.
So do I have, so look, I can also implement this get connection between, right? So if I have this, I just need to get this code here and just alter it just a little bit, and it will get me the implementation for get connection from source to, right? This one.
Yeah.
So yeah, okay. So what I'm doing is here, I just need to take the second part from the iterator, right? Like this. So the iterator usually contains a pair. Let me just make sure, okay?
But isn't inbound connections useless?
No, it's not. It's not useless, because you at some point you will need to know all the edges that go into a node in the same complexity as the ones that go out of the node, okay?
Oh, okay.
You know what I'm saying? So it has symmetry. If now you need to see the outbound neighbors, it doesn't mean that you don't have some problems in which you need to see the inbound neighbors. You reverse the edges or something, you know. So it's symmetrical. If it will be very easy to get the outbound, but it will be harder to get the inbound, right? Okay. Oh man, but look, there is contains. It's okay. It's okay. Let's get value from C++. Unordered map. Iterator. But I think that's it. But let's check, okay? It first, it second. Okay, so it's not a function. It's just a pair. Okay, so I get the code from that, and also if I need to get the edges between, I need to do this, right? I need this code now, and I need to access, yeah. So I need to do all this again here in this function. Maybe I should have, yeah. I'm gonna refactor the code, man. Everything that's being repeated, I'm gonna put it in one function. So now I get, this is the connection ID, and based on this connection ID I can get from the connection collection, right? So this connection will hold all the edges for said connection, right? So now since I can reach the connection element, I will get the edges of the element, okay? So what I need to do now is that I need to find it. So it's gonna be auto connection iterator in this connections dot find based on the connection ID I just received, right? So now I get I need to return
set, right?
Yeah, so but that's exactly this okay, dot second, right, and that's because you can see that in the dictionary for the connection, no, I need to get the edges, right, so it's second dot edges. Do you agree? Are you following, or did I lose you along the way? So con iterator is it's the iterator in the connection dictionary. Now I have a pair there, so the iterator points to a pair that has the first is the ID, I don't need that, and the second is the connection, but within the connection I need to access its edges.
Oh, okay. Yeah.
Okay. Okay, so okay, so I need to also label these variables, right? Like source node and destination node, and then again source node, destination node. Okay. Cool. So I got this. Okay. Maybe I need to check this number of connections. That's just like, this is easy to implement, right? So it's connections dot size. Okay, so I should save it and just see how many errors I got. What? And now let's test it.
Damn.
So what is this? Okay, let's see. Why is there an existing ID?
Because we didn't add the edge.
Okay. Yeah. So I need to. Yeah. You do have a point. So now I just okay. So now I'm saying like this is where we left off, right? So I'm saying if this is a connection, right? Between SRC node and DST node. Or if it's not, if you don't have a connection, right, then we create one. Correct?
Correct.
Okay, so now I need to have some sort of a variable telling me how can I add, a base for the ID of the connection, right? So this is a bit weird because I need to manage the connections, right? Because I said that I have a connection and each connection has a unique ID that I have to maintain, right? So how do I maintain the uniqueness of IDs? So I need a basis for this, right? Let's say I maintain a private basis for connection IDs. So when I start my implementation, I need a basis, right?
Is that member of connection?
What? Yeah, but what? Just a member of the class. What if I do this? No, I'm gonna. What about this? Hmm?
Okay,
So,
that's one way of doing it.
well, I'm saying I have this instance that holds, and if I increase it all the time, it should be unique, right? So, here,
Yeah.
I'm gonna say this base, cum i-am zis? I mean, I have it on the
Base ID.
connection,
Something.
okay. Okay, so it's gonna be how do I insert a new stuff? So it's this connections insert, right? And now I need this as an ID and I need a struct, right? It's what's it called?
Yeah.
A connection, like this with capital C, right?
Right.
Okay, so now I put the connection as the value and I insert it, right? That's it, correct? And
Should work.
however, I need to get the connection ID, right? And oh,
Okay.
no, that's not, I don't think this is enough, right? Because now I need to create, oh, yeah, okay, got it. So this is not enough because I need to put it in the inbound and outbound dictionaries as well, right?
Right.
So it's gonna be this outbound connections, right? So in the outbound connections for SRC node, this is the out connections, okay? So I'm gonna say auto out connections. Okay, so I get the out connections for the source node, okay? I know that the source code exists, so
Okay.
okay, but what if, okay, this is tricky. What if the source node doesn't appear? Okay, so I need to check something again here, right? I'm gonna be like if, right? These outbound connections doesn't even have outbound connections. I'm not. It's not gonna be. I'm gonna have find. Okay, so it's gonna be out connections iterator. No, so I'm gonna have to check it. Let's see how do I go about this. Okay. I'm not gonna be coding much longer, okay? Because I'm gonna need to finish this off. But let's see about this, okay? So first, I need to check to get the iterator for the outbound connection. So it's gonna be it out connections, and this is gonna be found by the node, okay? If the iterator is missing, I need to create, so I'm gonna say if it out connections is equal to this outbound connections So this outbound connections.
We would need to create a map or what?
Yeah, of course. We need to create a map. Of course we do. So in that map we need to put the destination, right? And blah 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 blah, because now the outbound and the inbound connections, like, they're empty, right? This is like the most important the most important operations now. Like, it goes through all the graph, right? So if this is the end, my friend, atunci we need to create a new map, right? The outbound connections map. Okay, so it's gonna be an unordered map of what and what, int and int, right?
Destination node.
So it's the destination node and the code of the connection, which I have. It's the base ID connections, right?
Base ID connections.
Yeah. So
Yeah.
okay. So now let's see what I've got. So unordered map of this is out connections, if that's happening, right? So I'm creating this guy. Cool. It's all good. And now I need to create, to make sure that I have an out connections for that. So it's gonna be this, this outbound connections. So here it's gonna be outbound connections. How do I it's insert, right? So it's gonna be easy, right? It's just a pair of the source node and the out connections, right? But it, mind you, it's an empty dictionary now. Okay, good. Now, moreover, okay, in this context, I mean, no, I can get out of this, right? Because now I'm ensuring the fact that whatever happens next, I have an array of dictionary of connections, right? Okay, now I have to check if the okay, so now it means that if this is at the end, it means I don't have one, and it means I'm creating one. But now I need to repeat this, right? I need to repeat this line. No. So if let's see, can I do this? I think I can do it better. I can do it like this. How about this? Now if I do it again, if I find it again, it cannot be empty, right? Because now I have the out connections, and I guarantee that I'm on the out connections right now. Does it make sense?
Yeah, it does.
Okay, so now I need to get the dictionary within the dictionary. So it's gonna be out connections, out cons, let's say, and this is gonna be the IT out connections. I'm gonna get the information out, but it's a pair, so I need to take the second part, which is the dictionary, right? So it's gonna be second, and in this I'm gonna have to check if I have the destination node, okay? Because maybe I've had another edge for the source node, but the destination node is the first time it appears here, right? And now I need to do an auto it dest node, which is outconst dot find, and now the keys in outconst are the destination nodes, right? So it's dst node, and here I need to check again if itDest node is in fact equal to the end of this, so it's gonna be outconst end. So I cannot find one. I need to create an entry for this. Again, it's the same principle, but now in the unordered map within the unordered map, correct? So I need to create what? I mean, I don't need to create anything. I just need to insert into this, right? So it's gonna be outconst. Yeah. So it's gonna be outconst dot insert the pair of destination node and what? The ID of the connection, right? Is gonna be this base ID connections, right? Okay, which I'm not incrementing, only after I've done this, right? So I insert this, and now I am ensuring that the IT destination node I do it again, so now it has to be valid, right? And I'm gonna find it once more. So now I'm sorry, I said if instead of IT. Okay, so the iteration of the destination node should now return, if I take the second part of it, so it's gonna be auto, it's not, it's gonna be an int connection ID. So let's go back, okay? So I created a new connection, right? I put it in the ID base. Now I got the ID of that connection, right? Do you agree? At the end of it.
Yeah.
Because if I check here, it can be two scenarios. If this turns false, it means that either I have nothing, neither for the source, neither for the destination, or I have the source but not for the destination, okay? So at the end of this, I checked these two cases. If it's the first case, I need to create both the source and the destination in the outbound connection, right? And now I should have the connection ID should be the same as these base ID connections, right, guys? So the connection ID now is the connection that either it has been created between the edges or already existed between the edges. So now, since I have this, how do I get this? I just take the itDest node and then take the second part of it again. Okay, so now if I have this, I'm gonna go into the connections. So I'm gonna get the connection, I'm gonna say auto connection equals this connections at connection ID and with the connection I'm gonna add, right? So let's see.
Connection dot edges.
So maybe I have to do this. No, I have to do this beforehand, right? So this line here, in the same sense that we did it before, I should have it here. So it's gonna be, and if this connection doesn't exist, right, because I check, this is the same as checking if there is a connection there, right? Or no, this will break. I shouldn't do this. Okay. No, I'm gonna do, this is not a good idea, okay? This is a bad idea. So I will create here, I will, okay, what am I gonna do here? So I need this connection. No, I need the connection between these nodes. Okay, so here I'm gonna say auto connection, it's gonna be is connection, right? No, get connection. Did I implement the get connection? Yeah, I did, but I didn't think about one aspect of it. So yeah, okay, I need to refactor it, but just a little bit, okay? So it's gonna be like this. It's gonna be like, correct me if I'm wrong, okay? I'm gonna try to do this. Okay, so it's gonna be auto connection, this get connection, between the source node, because there's only one connection between those guys, right? And the destination node, and it will break in if there's no connection, right? Let's see. The at remap find map at. Wait, out of range exceptions. So cool. So I'm gonna catch an exception, right? So it's gonna be, I'm gonna try to do this. Once I get the connection, I'm gonna add the edge to the connection. So I'm gonna say connection. Uh-oh. I think that get connection between, right? Get connection. It just gets me the ID. Okay, I like this. Okay, so it's gonna be int connection ID base get connection between, and then let's see the other one. I need to have, where is that? I need another function, right? I'm saying I need a private function called add to connection. So what I need is an int which is connection ID, and also I need the do you agree?
Yeah.
So what I'm gonna do is I'm gonna say that it's a dictionary, right? The connection, the structure, it holds a dictionary.
Set.
Is it a set? It's even better if it's a set.
Or actually.
Unordered set. Yeah. Okay. Oh, so I only need to so it's gonna be edges, insert, and only the edge ID. Right, so I don't need the edge. I just need the edge ID. Right? Because I'm putting IDs everywhere I can. Cool. Good. Okay. So this will add the edge ID as part of the... Okay. So let's...
Actually, there's a bug there.
Where?
Also.
Where? Up? In this function?
Yeah.
Where?
Yeah. So you have insert just edge ID, not edge.
Yeah, you got it. Thanks, mate. That's good. Thank you. Okay, so now with this, what do I do with this? So let's get back and wrap this thing up. Okay, so here I'm gonna have to say this. How did I put it? Add edge to, what was the name of the function?
Connection. And edge connection.
Add edge to connection, right? Okay. So it's connection ID and edge ID. So yeah, I need to add this edge to the edges, right? So it's gonna be this edges insert edge ID and E first of all, right? Because I'm ensuring that now, okay, so if this happens, everything goes okay, but this is equivalent to accept, to catch, right?
Catch.
Do you agree? Because if this fails,
Yes.
it's the same thing that we did in the other function, okay? So I'm gonna catch it, and at the end now I just need the connection ID. I don't need the connection anymore, right? So I'm gonna do the same stuff here, right?
Isn't the function called add edge to connection?
I'm sorry, what? Add edge to connection. Okay. More, yeah. That Yeah. Okay, I'm gonna keep it consistent. Okay. Is it correct though? Let's see. So yeah, because now I inserted the ID, the connection ID, correct. But I think this can be written differently, right?
Yeah, it surely can be.
Because this is duplicated code, so I think it was better the way we wrote it before. So let's say now if I can get the if I can ensure that I can get connections between this, okay, so I'm gonna take this code, oh sorry, I'm gonna take this code out and just I'm gonna put it here, okay. So this happens in the same way in both scenarios, right? Look, it's the same. I need the connection ID and the edge ID, right? So this will get out of here, and now all I need to do is to find the when does this happen, okay? And this happens when I don't have, it was exactly like I tried to make it in the beginning, right? So it's gonna be,
yeah,
if there is no connection, right? If there is no connection, we create a connection. Is connection, așa era? Sau is connection between?
Mai țin minte.
Is connection, okay? Dacă if it's not a connection, we make a connection, okay? So yeah, okay. So it's from the source node to the destination node, this2 node. If there is no such thing, so that's false, then I have to create a connection, which happens here. And now here, when I try to get the connection between this and that, it has to be a connection here, right? And the only thing I need to do at the end of this is to increase the base. Boom. How about that? Right? And now, in the end of it all, once I've successfully created the edge, I add the edge to the connection, and boom goes the dynamite, right? Okay, I know, this is not entirely, I mean, it's not the entire implementation, because I also need to take care of the inbound connections, you know? So this needs to be duplicated, but I won't go into that now, okay? This is what I did now. Let's see if it has errors. Okay, what was this? Holy smokes. Okay. Oh, I put brackets, more brackets than I should have. Okay. And we will wrap it up with this, okay, guys?
Oh, that's the only one.
I'm sorry? Ah, yeah, where is it? Oh, here. Yeah, but it put it...
The only error.
It's the only error, but it comes twice. Okay. Damn. Okay, so... let's check this and then we'll go home. So, graph test, right? So, where's the error coming from?
Existing ID something.
Yeah, what? So it's within this add edge, right? is it before? Is it this one? Oh, I think I chose existing node ID.
Iteration failed.
No, man, I forgot to change it, you know, because I changed the message. Alright, so now, so it, yoy, okay, this, you know where this is coming from, right? I'm using an at somewhere and it breaks, it's not doing, okay, I'm close to finishing, man, this is good, right? Can you feel it?
Yeah.
So here in the implementation of add edge, at some point I'm using at somewhere when I shouldn't, you know, but where is this? So okay, I don't know, no, let's do it like this. Destroyed whatever, okay, so not like this, quit, yes, okay, so I need to compile it with -g, and then let's see what happens if I gdb. Destroying a multigraph, so it's after, let's do some prints, okay, and we'll be done with it afterwards, okay, good, let's, oh man, it's 9 o'clock, holy smokes, graph test, right? So let's see what I've got here. So where does it print my, so this is where it prints it, it goes here, adds node, a set number of nodes, I guess. Let's comment these 2 lines, okay? Crap. Without the GDB, let's. Okay, so it's because of that particular set little function, right? So if I'm uncommenting this, compile it again. Yep, woohoo! Well, at least we know where that's coming from, right? So keep it like this, and we're gonna do the most peasant way of debugging stuff, okay? They want to come up to this, but they left me no choice, right? So, I mean, I left me no choice, and I'm tired now, so I'm gonna print the heck out of it, right? So here, it's gonna be cout check if source, no, check if there is no other edge with same ID. Ta-ta-ta. Boom. Okay, so now I'm gonna copy this and change the, okay, so the most peasant way of debugging. Check if there is an a source ID, a valid source ID. Boom. Maybe, okay. Check if there is a valid destination ID. Cool. Then create edge. And insert it. Oh man, is connection. Holy smokes, man, this is gonna break, because I'm not using find in it, I think I'm using at. let me see. Is connection, where do I have that? Yeah. Holy smokes, look at this. Right? So
Beautiful.
So maybe I can do this. It's a quick, don't turn on me guys, okay? It's just a quick fix. Well, I'm gonna just remind me to pick it up from here next time, okay? Ah, what did I do now? Ah, I didn't close the parentheses like I should have, right? What did I do? Tum. So what is this? What did I do? It's a syntactical error, but how? I need to catch something here.
Maybe yeah, try to catch the STD out of range.
Okay, so it's gonna be... I mean, it has to be an exception, right?
Yeah, okay.
Okay. Not cool. Why segmentation fault?
Oh.
Yeah. Not cool, man. When you try to hack it. So, if... Okay. Nah, I'm gonna do it properly, okay? I'm sorry, that it's just beneath me, man, to just hack it like this. But then I'm finished, okay? So here I'm not gonna do at. I'm just gonna do find, right? And then I'm gonna say if man, that was a bad code. And okay, this is correct now, right?
I think you have to write out connections that second.
Yeah, I get it. Yeah. Where is that? So yeah. Și acolo trebuie să scriu. Da. True.
Îți plac săgețile?
Yeah. Îmi place mai mult pe iterator să pun chestia aia, știi? I don't know. Segmentation fault cordant. Man, why? Let's see. Let's see why. Okay. Okay, so let's comment these lines here, because maybe that's where the error comes from, okay? So okay, clearly it came from here. So man, this is exceeded what I expected for this, so I'm gonna wrap it up soon, okay? But let's see where, just locate the source of error and we'll be done with it, okay? I'm sorry I'm keeping you this long, guys. I bet it's a stupid not paying attention kind of error, right? But we'll narrow it down. Okay, so let's see what is
I
this.
think it's the last two lines.
The last two lines. Oh yeah. So I should I should comment this up until here, right? And then move from up down. Okay. Oh. Yeah, I need to erase this one. Yeah, correct. Yes, of course. Yeah, I get what you're saying. Because I'm not okay, so this should be okay now. Yeah, okay. Guys, we're going in. And then we're going to eat. Or at least I'm going to eat. Okay? So, hopefully... Okay, so let's... I can do this, right? So I have to have this regardless of what's happening. Okay, so I need to erase this, and now I'm going down a notch, so I'm moving it down a little bit like this. Probably it's from here, right? So let's see. No, okay. Woohoo, we're moving on.
Mă aștept să fie doar ultimele două linii.
Zici? Bă, deci steady. Da, eu zic că poate ai dreptate. Maybe you're right. So okay, let's do this thing. Ce-am făcut iară? Iară n-am... Man. Of, Doamne! Dar pe care, man? Că... Doamne, pup în două, Doamne. Da, am șters acolo de asta de aici, așa? Când am scris comentul. Corect. You must be right, man. Yep. I bet you're right. But why am I wrong? Hehe. Right, those are the two pesky little lines that form this error. Let's check them out.
Let's use find instead, maybe. Oh, actually there's no at. I thought there was an at there.
There is an at in get connection between, man. But now there should be...
Oh.
You know, there should be... Let's use this. Is connection... I mean, no. Get connection, let's see. Get connection between, that's... Yep, there's your at right there. But why isn't there... Like, there should be... Right? There should be... Okay, let's change.
Yeah, it should.
No, like let's see if we added, if we did what had to be done, then it means that there should be a connection. Get connections between, okay? So this get connection between means that I have to check. Man, I don't think this is okay. Is it okay? Get connections between. I need to go to the outbound connections at source node. Okay. But this is bullshit because it will break if it doesn't have. So I need to recode this one. Okay, so I need this. Okay, this is a good implementation. I'm gonna take this implementation here, right? Okay, I'm gonna put it. This is what I need, right? Okay. And now let's see what I've got. So I'm finding the source node. Good. If this I need to throw an exception here, right? It's a what is it? MultiGraph. What? Okay, MultiGraph exception.
MultiGraph exception.
Okay. Alright, so if it passes this one, I'm gonna throw, so if dacă ăsta e egal right? So if I have this one, what does it mean? Now if none of this happens, I'm gonna get the connection, right? So it's gonna be the like this, right? Yeah.
Yeah.
Mutli. Misspelled.
And you also forgot to delete something from the comment.
True. Okay. You mean those two lines? What? Oh, this.
On the last line.
Sure. So it appears that. Okay. Let me just check here in the. Where is it? So where I'm gonna catch the errors to see where the exact exception, right? And I'm gonna print the message of that. Well, it's not an STD exception, it's my exception, like multi-graph exception. Okay, so I'm gonna print, what was the name? Get MSG, right?
Yeah.
Okay, so no connections for destination node. Okay, so it's because of the destination node, correct? So let's see what that is, right? So the idea is that maybe I didn't create, did I do it all the way? So, oh man, I inserted the out, okay, destination node, so base ID, so outcons is that like get connections between, right? It looks into the out connections of the source node, and I need to put if the destination node is the end, I need to outcons insert the destination node. Yeah, but it, let's see if it gets here. Maybe it doesn't get inside of this, right?
Yeah.
Let's see. No, it gets there. Okay. Okay, this is strange, right?
Good.
So it gets there, it inserts the pair inside the map outcons, right? Outcons being okay. Okay. Oh man, okay. So yeah, okay. This is it. Okay, okay, I got it. Okay. So check it out. Because I created a copy and it copies that stuff. Do you get it?
Oh, there.
So so yeah, that's the problem here, man. Check it out. So it's with this stuff, because I should get inside. Okay, so let's see if I put how did I put it? I put just auto, right? I don't, oh, it's just, oh, like this, not const. Okay, I guess. Okay, let's see. outbound connections. Iterator. Yeah, I put it wrong there. Okay, so that's wrong. Yeah, but the other one, it should work just fine. So this, I don't need it here, but I do need the other one as a reference, I guess, because outconst should be modified, right? So okay, okay, that was it, right, guys?
Yeah, I think.
So I think we've done it, right? So yeah, I was afraid I was gonna do a mistake like this.
It worked.
Huh? What did you say? You can't believe it worked?
Can't believe it worked.
Well, it worked. You know, I'm gonna say it like Homer Simpson, you know? It worked so far. Like, now we know if it worked, right? And boom, it will crash. Hopefully not. Okay. This was cool, man. I'm sorry it lasted so long, okay? But we got something, okay? Thank you guys for staying with me, okay? For this many hours. So, see you soon. See you tomorrow. Bye bye.